ഇപ്പൊ നമ്മുടെ 5-5 ടോക്സിന്റെ 4th വീക്കാണിത്. ഇവിടെ കൂടിയിരിക്കുന്നവരെല്ലാവരും ഞങ്ങളെപ്പോലെ തന്നെ ടോക്ക് കേൾക്കാൻ ഭയങ്കര എക്സൈറ്റഡ് ആയിട്ടിരിക്കുകയെന്നറിയാം. നമുക്ക് വേണ്ടി ഇന്ന് ടോക്ക് എടുക്കാനായി എത്തിയിരിക്കുന്നത് സുരേഷ് സാറിന് ഔപചാരികതയുടെ പേരിൽ മാത്രം പരിചയപ്പെടുത്തുകയാണ്. നിങ്ങൾക്ക് എല്ലാവർക്കും അറിയാം സാർ ആരാണ്. ISRO ലിക്വിഡ് പ്രൊപ്പൽഷൻ സിസ്റ്റം സെന്ററിന്റെ എൻറ്റിറ്റിയായ സിസ്റ്റം റിലയബിലിറ്റി ആൻഡ് ക്വാളിറ്റി അഷുറൻസിലെ ഡെപ്യൂട്ടി ഡയറക്ടറാണ് സുരേഷ് സാർ. LPSC ഡെവലപ്പ് ചെയ്യുന്ന എല്ലാ പ്രോഗ്രാംസിന്റെയും ഇൻക്ലൂഡ് ചന്ദ്രയാൻ 3 മിഷന്റെയും ക്വാളിറ്റി അഷുറൻസ് അദ്ദേഹത്തിന്റെ റെസ്പോൺസിബിലിറ്റി ആയിരുന്നു. LPSCയുടെ സ്റ്റോറബിൾ സ്റ്റേജസിന്റെ ഗ്രൂപ്പ് ഡയറക്ടറായും L110 പ്രൊജക്ടിന്റെ പ്രൊജക്ട് ഡയറക്ടറായും പ്രവർത്തിച്ചിട്ടുണ്ട്. ISROയുടെ ടീം എക്സലൻസ് അവാർഡ് 2 തവണ കരസ്ഥമാക്കി. അദ്ദേഹത്തെ പറ്റി പറയാനാണെന്നുണ്ടെങ്കിൽ ഇനി ഒരുപാടുണ്ട്. ഇന്ന് അദ്ദേഹം ഇന്ത്യയുടെ ഫ്യൂച്ചർ മിഷൻസിനെ പറ്റിയും അതുപോലെ നിലവിൽ സ്പേസ് മിഷൻസിൽ ഇന്ത്യയുടെ പൊസിഷനെ പറ്റിയാണ് സംസാരിക്കുന്നത്. കൂടുതൽ ദീർഘിപ്പിക്കുന്നില്ല. പോയട്രി ഓഫ് റിയാലിറ്റിയുടെ ഈ 5-5 ടോക്സിലേക്ക് ഏറ്റവും അഭിമാനത്തോടെ സുരേഷ് സാറിനെയും നിങ്ങളെ ഓരോരുത്തരെയും സ്വാഗതം ചെയ്യുന്നു. അപ്പൊ ഇതുപോലെ തന്നെ നമുക്ക് ഇവിടെ ഗൂഗിൾ മീറ്റ് നടക്കുന്ന പോലെ തന്നെ ലൈവ് സ്ട്രീമിംഗും ഉണ്ട്. അപ്പം കുറച്ച് ആൾക്കാർ അവിടെ ആയിരിക്കും നമ്മളെ കേൾക്കാൻ വരുന്നത്. ബാക്കി ആൾക്കാർ ഉടനെ തന്നെ ജോയിൻ ചെയ്യുന്ന പ്രതീക്ഷിക്കുന്നു. സോ വെൽക്കം സർ.
Hello.
Yes, Tanya is audible. So, good evening all. Thank you, Athena, for giving the introduction. And let me thank, first of all, Karthik for giving me this opportunity to give a presentation to this forum, which is very much interested on the science. Am I audible there, Athena? I am audible?
Yes, sir, yeah.
Okay. Is it clear also?
Yeah.
Okay. The time given is 30 minutes. I will try to complete, but then Space Odyssey of India spanning more than 65 years, covering in a, and that too, I mean, I may have to talk something up to 2040. So it is may not be possible to in a complete way I can cover all the activities in 30 minutes. Let me try. Wherever you are having any clarifications required, you can stop me and ask, or otherwise at the end there can be a question answer session also possible, and I will try to cover to the extent possible. That's all. And if you are ready to continue for some more time, then it is well and good. Otherwise we will close it by 8 o'clock. I will also try to finish the present. Those slides are more. I will try to finish the presentation by 8 o'clock, so that wherever it is not needed much explanation, that I will skip fast and then move forward. So I will share my screen first. I hope presentation is visible.
Yes, sir.
Okay. Once again, good evening all. I will try to cover the space exploration, not only the Indian part of it. There are certain aspects which I must talk to young students as well as maybe some seniors also there. I think Rajan sir is there. I have seen him. So there's something else extra also I will be covering, not only the Indian part of it, something more, which is I have cut short many of those things, but still some area will be there in that. Without that, because now the space exploration is a global phenomenon, not restricted to one nation or in their capability. It is all collaborative efforts are going on all over the world. Now, when we talk about future, definitely we should know what is the history or background or behind that, what happened. So in that aspect, a few slides on that. If you look at the history of rocketry, it started very late, something around 1950, 63, that time frame, or 59, that time frame. But then people were having the urge, or they were always eager to go up, because they are not having the capability to fly like birds, and they were always envy about that. And there are many mothers, they were trying to make it. And these are all some of the early attempts by human being to go to space. And one particular person, this Van Hue flying chair, he has put up, I think, more than 40 rockets, or it is something like our small padakam, what will say that, whatever using our fireworks, and put it on the chair, and then he sat on it, and maybe he is the first person not gone to the space, I will not say, but he has vanished to the space. He has never come back. I think it's explored, and he lost, and he has vanished, and that is the contribution he made to this space exploration, I will say that way. Now, really, the space exploration or the use of space has come a meaning in when the Sputnik 1 has reached the orbit, and it could complete 1 or 2 revolutions, and it is able to transmit from the outer space to the it's only a beep sound, but then that was the beginning of the space era of total humanity. And subsequently, you are all aware, there was a big war. Actually, it's a competition. We call it as economic war or military war or whatever it is. It was a war between two countries, USA and USSR. Not physical war has not happened between them, but then they were always competing to defeat. I will say they were trying to defeat each other in getting achievements. That was the point. So then onwards, once they put the Sputnik has gone into space, then onwards, immediately the Americans have put it. Then there was a big competition between these two spacefaring nations, and no other countries were in the picture in any way. And there were so much of things happened. You know that what happened in 1969 when the first man put his foot on the moon. Up to that, and subsequently, because of the economic reasons and so many other things, both of them stopped the competition. And one thing I want to tell, that during that competition, the rocket made by the USA, America, that is Saturn V, that is the biggest rocket, I will say the most powerful rocket ever made by mankind. Maybe now the Starship, which is made by Elon Musk, is going to defeat, but Starship is set to become operational. Okay, of course, I'm not undermining the USSR contribution of N1 rocket, which was not a success, but it was much capable than Saturn V, but that has not gone into it was not a successful launch vehicle, I will say. But otherwise, Saturn V was a really successful thing. It could take something around 130 or 140 tons of payload to low Earth orbit, whereas even now our capability is of the order of 10 ton or so. That is the magnitude of order in which they were at that time. Now, the major space milestones, I am not going to dwell on this. It is all well known. Only one thing is, the second person is our Colonel Rakesh Sharma, and the man has gone from India to the outer space. And then the space shuttle, this has come a big way as a change of, I will say, a paradigm shift when we are trying to land back, or reusability part of it. This was one major thing. And then came the biggest international collaboration. This is what I was telling. Nowadays, the collaborative effort only happening in the space. There is no competition between the countries to defeat or become superpower or something like that. It's all efforts are together. They are working, harnessing way. They are working on this, on the International Space Station. Now, just next slide is, this is I just put this photo only to just to say that can anybody tell that who is this person? Maybe the person who is wearing the identity card is myself, Sureshkumar, but the other person, anybody can guess who is this person? Am I audible? Hello? Am I audible? Okay. Madam, I am hearing you, but I was putting a question whether this person is identified by anybody. This is none other than the Rakesh Sharma you have seen in the previous slide. This is the Rakesh Sharma. I got an opportunity to meet him in the last 2 years back in Bangalore, and I was fortunate to. He was kind enough to be a pose along with me for a photo. That's the greatness of this person. Such a nice person, humble person, down to earth personality. We can talk anything with him. And then for India, when it comes, it's a humble beginning. In 1963, in a modest way, we started the operation in Tumba. You all know that. The Nike Apache has gone in 1963 from Tumba. It was a imported rocket launch. You know what is the importance of Tumba anyway. Next slide we'll talk about that. This is because Tumba is lying on the magnetic equator, and very rare landmass is available on the magnetic equator. So that is why Tumba has become a very important place wherein on this equator. Hello. അതെ അതെ ഇവിടെ കൊടുത്താൽ മതി, ഞാൻ മീറ്റിംഗിൽ. Hello. Sorry, there was another call. So this is the place which we, anybody talking about ISRO cannot skip the presentation without this mentioning this particular place. This, even now you are coming to VSSC in Trivandrum, you will be able to see this beautiful church. The Indian space program started in this church. I am forced to say a few, but okay. If I talk, I need to talk at least 10-15 minutes on this particular place. Otherwise, I will not be doing justice for the human beings who has given this church for the space activities of ISRO. It's something great. The story itself is a long story. Anyway, I am not talking about that story now. It is it will take a lot of time. Now, now coming to the space activities in all over the world, there are so many activities were happening up to the last decade, mostly independently, and subsequently, all of a sudden, on the last decade, there was a big change on the overall the space activities. Once the man has gone into moon, and subsequently the Apollo missions were called off, there are 12 people have landed on the moon. And then subsequently it was called off because of the economical issues and so many other things. But then in the last decade, so many things has happened. And one thing is some of the major launch vehicles were called off because all were phasing out. Then they were all making new rockets all of a sudden. And the most important thing is the private players with new propulsion system, they were coming. SpaceX, you know, that Blue Origin, Rocket Lab, and so many things. And one more thing is that it is the cost effectiveness that has become prominent when we are talking about the rocketry and rocket related activities. Otherwise, earlier it was all done by government and there was no the concern of the cost effectiveness. Now that has come, and new propellants, so many things have come. And then the big satellites has moved out to small satellites. You know that Starlink is launching something around 6,000 satellites for a constellation, that type of things. Each are around 200, 300, or even less than that. I think it is less than that. We launched 36 satellites in one launch vehicle itself in GSLV Mark 3. Then, of course, the SpaceX has come with a wonderful rocket, Falcon. You can read on the internet. So many things we have to talk about this particular launch vehicle. And they have made the Starship also. You might have seen in many of the videos and other things. Then, of course, Virgin Galactic, Blue Origin, all started with space tourism, and so many things have happened in the last decade. And then global trends in space sector for the next 5 years. Now, when we talk about the future for the next 5 years, how the space sector is going to be changed or going to be transformed. See, in 2022, if you see the revenue or the economy of space activity is only 464 billion. Whereas now by 2050, another 20 or 25 or 30 years, it will be of the order of 3 trillion or even more than that. So some survey says it will be 4 to 5 trillion. and the drivers are this. I'm not going to dwell on this. It is not like simply the space exploration and putting rockets into the orbits. That is not the thing. There are so many other things. Climate and environmental protection comes into a big way. Then another thing is the national security and defense, then in-space manufacturing, then sustainable development goals, then LEO commercialization, you know, that tourism, telecom. This is what I was telling. Virgin Galactic has started the tourism itself. Then space situation awareness and traffic management. It's a very big topic. There are so many, even the institutes are offering courses on this space situation awareness and traffic management. Then cislunar space. This cislunar space is the space between Earth and the Moon, and its commercialization. It's a very big area. Yeah, each of the spacefaring nations are trying to do something on that docking, and then making it to further interplanetary motions, interplanetary movement. These are all very, very interesting topics. In interplanetary exploration, crewed and robotic, you know that even the Elon Musk is trying to put man on the Mars. That type of thinking is going to is there in the. It's a reality. It is going to happen maybe another 5 or 6 years. And then space-based energy and even agriculture. You know that in the last PSLE C60 mission, I think you might have read in the newspaper or in the website, there was, even we also tried the pyre. We tried to grow there. It has come out successfully, and 8 peanuts, but 8 that pyre was taken, and then it was grown also. It has come out. It is able to sprout. That itself is the message. And one more thing is this convergence of between space economy and global economy. The space economy is going to play a major role in the global economy also. So the global trends in according to the space transportation system is this: that is, heavy and super heavy launch vehicles are required to go to Moon, Mars, and space tourism and interplanetary exploration. So many things. Then nuclear and thermal propulsion. Then LOX methane is a very cost-effective propellant combination. Recently started using it. Elon Musk is very effectively using it, and we are also, ISRO also having a launch vehicle design is going on with LOX methane. That's the latest propellant combination. Then nuclear propulsion, we are in the front on that. Then recovery and reusability is a major thing. Then space traffic management, development of technologies for cryogenic propulsion for long missions. That's a very major thing. Then advanced material, re-entry and landing, point-to-point space travel. Now the transportation between the countries. Now if you go to America, it will take minimum 12 to 15 hours, but that can be reduced to 1 hour if you go by space. So these are all going to come into reality.
Hello.
Am I audible?
Yes, sir.
Okay. Then on the satellite part also, so many major trends are going to happen. Miniature satellites, you know, you might have seen PSLE has flown 108 satellites. That was the record. Now recently 131 satellite, again SpaceX has put it. So our record was broken by, and records are for that to be broken. Otherwise there is no meaning in having a record. Then the data transfer rate, the laser-based data transfer. Now we are talking about megabytes or Mbps of data transfer. Even you see for 4G, 5G and all, we are talking about 100 megabytes, 100 Mbps or 15, 30, 40. But then it is now in the gigabytes range of 100 gigabytes per second. That is the way the data transfer is going to happen using laser technology. These are all, I think, you can read in the internet and then get more and more awareness on that. These are all the areas in which you young scientists has to work on that. These are all the areas which are new opportunities for all the scientists and engineers coming in the future. Then comes, this is a very, very important slide. Please note that it's a sustainability goals. We are talking about something we are using or consuming our own resources, and then the sustainability in space application is also a must. You cannot spoil the entire outer space with so many debris and other things. There are so many issues are happening. Even some of our launches are getting postponed maybe 1 or 2 minutes just to avoid the collision between the certain flying objects. So debris orbiting spent stages removal. Even you know that the last PSLV mission, we had one more experiment, and it just come a big way in the today's newspaper, Madhubhumi newspaper, also news heading as a big heading. We are working the robotic arm experiment has successfully deployed and did some operations. Ultimately, the goal is to repair the satellite or grab the space debris coming around the satellite and then save the outer space for future operations. Then ion propulsion is a very promising thing for long journey in the outer space. Then always use, see, you know that the propellants whatever using for the rocket propulsion other than the hydrogen and oxygen, all are toxic. Maybe LOX methane is somewhat semi-green, I will say, but otherwise all are highly poisonous, and it is really, really dangerous. I don't know if anybody is aware of the unsymmetrical dimethyl hydrazine what we are using for our rocket propulsion. We are filling it remotely, we are filling it, but then it is for ppm exposure for 1 hour is dangerous for our, it's a carcinogenic propellant. And you know that 4 ppm we will never even smell. That's the thing. Then additive manufacturing is come in a big way. This is why the most of our, even we have also demonstrated additive manufacturing of the rocket parts. It's very, and even space also. Once you master this additive manufacturing, you can even build the systems in the space. Then alternative launch vehicle, that's a different area. Even the spin launch you can see in the internet. And reusable launch vehicle, this has come in a big way. And the first one I told you, this is our American space shuttle. That was the demonstrated one. Subsequently, even the Elon Musk has started, SpaceX has reusing the launch vehicles booster stages, and there are so many. They are more. He has used, I think, more than 23 times one booster. That's a record for that. Then comes the ISRO's launch vehicle. I think these are all well known to you. SLV-3, the first one, and then ASLV, then the workhorse PSLV. We had the 62nd launch last week, PSLV C60. Then GSLV is there, and next month, I mean January, this month we are going to have one GSLV mission, and LBM-3, you know, that is a every time successful launch vehicle we are having. I was working in this on last phase of my, and I have worked in all the PSLE, GSLE, LVM3, and to some extent SSLV. This is an all solid, but there is an upper stage with small liquid stages. So that is why I was basically working in the liquid propulsion systems, and I got the opportunity to work in almost all the launch vehicles of ISRO. And this is the space port of ISRO. It is in Sriharikota. You can visit. There are 2 launch pads are there, and one more is going to come for our the NGL, new launch vehicle developed. This is our mission control. This is the launch control center. Is our mission control. It's a beautiful structure. You can see that. Then on when you are having satellites on the outer space, what are all the things it can use? Basically, there are 5 categories. That is remote sensing, that is viewing from outside and then getting more and more. That is a really very, very interesting topic, and there are a lot of private firms are coming to use this data and then using it for the different applications. I will say one example. You know that in Bombay, the banks have used this satellite data to see that whether one building was constructed properly or not, because they will be knowing the people were this claiming with some adjustment with the bank staff that the building is completed 70%, 60% or 90%, and you pay the money. So that was it becomes a problem, and they have referred this to some company, I think in a Bangalore based company, and they have using the satellite data, they proved that it was not correct. And there is another thing is one in North India and all, the crop insurance claim was there. Once the crop is not there or lost, we will not have any data whether it was cultivated there itself is also not. That type of activities were happening, and now they are using this remote sensing data to see that maybe the crop is there 3 months back, whether crop was there or not. That is well established. and some of the claims were rejected by the actual data. That is one thing of remote sensing. Communication, anyway, I am not talking about that. You are all, without that, even now our this meeting also will not happen. Navigation, yes, of course, every day we are using. Without navigation, we cannot now move around anywhere. That's the condition. Then scientific missions, so many scientific missions are happening, and we all know even the boundary of the universe. We are thinking on that. And this futuristic application, that is colonizing some of the things, the outer planets and all those things. These are all the applications of the satellites on the outer space. Then let me talk something, a few sentence on the our previous missions. Chandrayaan 1, you know that this is 2008, that the first we have put one small probe on the moon, whereas but then it could detect the water particles on the moon surface. That's the thing. Then Chandrayaan 2 in 2019, you know that it was a, though we call it as a failure, you know that when we travel 4,000 4 lakh kilometers, last 1.5 kilometer up to that it was all right, and in the last 1.5 kilometer things were going wrong. Then how far it was paining to us, but this has given a lot of lessons to us, and then we learned from that and we came back. That's why Chandrayaan 3 was a success. And then the Mars orbiter mission, this is the first mission by anybody successfully capturing the Mars orbit. That is ours was the first mission, whereas all other nations, they lost the satellite in the first attempt. Anyway, I'm not dwelling much on this. Then Astrostat is a multi-wavelength space observatory, is a very interesting satellite, very small satellite. 2015 we launched, and we estimated something around 6 years of life, but then still it is giving data to the scientists all over the world in different spectrums, in X-ray, then optical and UV bands. All the 3 bands, 5 telescopes are there, and we are getting the data on that. Then Chandrayaan 3, of course, is a very wonderful thing. I was involved from the beginning on this project, and I was there when the lander was landing. There were previous day there were problems, and we were forced to upload a correction in the program, and then that was worked. And on the day when the ramp was not opening, or the door was not opening, that was an issue. But then we could solve all those things, and finally when the lander or the rover came out, it was really a wonderful thing. And as our Devan Ramachandran, our dearest judge, he was telling in Kondamangal Engineering College, he was telling that the ISRO could stop the heartbeat of 130 crores of people. Really, it was really like that. It was a fantastic achievement. Then Aditya L1, again, we have is an Earth observation satellite. It is on the L1 point. We are there, so that is the Lagrangian point. There are 5 Lagrangian points around the sun, I will say, with respect to moon. Then this is the Earth, and then it comes. It is, anyway, I am not talking about the Lagrangian, but wherein it will be balanced without much energy. The satellite can be stayed there because of the balanced force of attraction between the bodies of celestial bodies. That is why the Lagrangian points are defined, and there are majorly 5 Lagrangian points. Even between the sun and between the moon and the Earth also there is a Lagrangian point. That's why cislunar space has become very important for the outer space explorations. And then Indian missions for reusable launch vehicle. This is one slide we will talk on that. There are RLV projects which has come big way in the paper. It has demonstrated its capability for reusability, and then so many two-stage to TSTO means two-stage to orbit. On that, this mission is also planned. I think next year this will be going on. These are all the plans we are having. Whereas some other countries already there in the space tourism, and we are also having a proposal to use some of our or we are developing actually for space tourism some of the rocket systems. Once our Gaganyaan program is undergoing all the tests, definitely India will be also there in the space tourism business. And then this is one area, Indian space policy. We cannot avoid because this is, you all know that 2023 onward there was a major change. Basically the thrust was we are having only 2% representation on the global space economy, and we want to increase to something around 10%. That was our idea, and that was why, and which ISRO, a single organization cannot do that. So we have to do it with private parties, private sector. There are, that something around more than 200 startups are there working in the space activities from 2021 onwards, but then policy came in 2023. There are big players outside: SpaceX, Boeing, Airbus, Virgin Galactic. So many are there. Here also we are having so many. I am having one slide on that. These are all the people who are working on that. Skyroot, that it was there in the paper. Then Airtel backed OneWeb. There is one. It's our own Airtel company is there for that. Then SRM University, every time they are using our POEM or any of our satellite capability or small satellite capability, they are putting some of the satellite. Then Thruva Space, Aknikul, these are all the well-known names every time it comes in the internet or in the paper. And we are always encouraging these youngsters. They have to come up. There are a lot of business opportunities are there for them. That is why the space sector reform has come, that private players have to come into. And the pros and cons, and I'm not talking on that. It's only the risk part of it. Otherwise, always the pros is there. That's why we are gone for that, because the cost effectiveness has to come when private parties are there. And then another, since you are all students, most of them are students and academicians, this one slide, we are always working with academia and industry. And without that, the academia interface, there are so much of solutions we got from many of our academic institutions, and they are taking Respond projects. It's a collaborative project between the academia and ISRO, and there are so much of outcomes are coming out of that, and many of those things we have used it also. So that is one part. You please note that any of the academicians are there, always ISRO welcomes this academia interface, and nowadays it is more required, because the scientific talent we need to use available in India, we need to use for this space activities. And now this is the slide on which I was told to talk on that. These are all the time frame. The plus means there are something more may happen. Then NISR, that, and the Exposat, it has gone. Now the up to all this yellow is already completed one. And then 2025 NISR, that is the world costliest satellite. It's a satellite collaboratively made by NASA and ISRO, means USA and ISRO. And this was it is supposed to be launched last year, but then there was some problem with the satellite, and it was be taken back to US, and now it has come back. And any point of time before the middle of 2025, this will happen. Then Disha is a twin satellite mission for ionospheric studies in 2 different orbits. It will be studying the ionosphere. Then Chandrayaan 4, this that this is a prestigious program approved by Government of India for sample return. It's a very really challenging project. I'll tell you something on that. Then Mars orbiter mission, second Mars orbiter mission with a rover landing on the Mars. That is another thing. Then EXO World Space Telescope, one more space telescope we need to put on that, because that the first one was 2015 we put it, still operational, but still we need another one. Then Venus orbiter mission is a major. Venus, that it is called as the twin. Anyway, I'll talk about that. One slide is there on that. Now this is the Chandrayaan. This we have already, Chandrayaan 3 we have already talked how we have gone. These are all available in the internet. These data are available, so there is no point in explaining further on that. This rover, and then rover came by Vikram. And now coming to the Chandrayaan 4. So it is really a challenge. It's really a challenge for us, and demonstrating the technologies for future manned missions. That is a fundamental thing. We are aiming for that. Then developing capability to bring sample from moon surface and Earth, and the scientific studies of lunar samples in our country. That is a fundamental thing. There is a typing. There is a one word extra there. So the salient features are 2 separate spacecrafts stacks in 2 launch vehicles mission and docking in orbit. This is what we are trying to. SpaceX experiment is only to demonstrate or have this capability. SpaceX has gone. Next week we will be having the docking experiment will happen, and once we are successful in that, then definitely we will be going for this project. This project can happen only with this docking experiment successful. Then landing on lunar surface, collecting samples is again a challenge. Though we had a drilling in the last our Chandrayaan-3 mission, we had a drilling which drilled up to 10 centimeter to see the surface temperature difference, and we have. It was a wonderful information. You know that once you drill by 10 centimeters, something around 20 to 30 degrees centigrade change in temperature is happening on the moon surface. That was a news to many of the scientific community. Then docking and undocking in lunar orbit, that's another requirement. Then return and re-entry to Earth sample, and then total cost is something around 2014 crores only is approved, and with that we are supposed to make this program happen. And these are all the 2 modules. First module will have the propulsion module. This propulsion module will take, this is, if you see, it is on the top, and it will be traveling in the other way, the upside down, and it will be moving. This fellow will be the top. The propulsion module will be pushing the whole the units to the up to the moon orbit, and then from there this re-entry module is coming. Then the transfer module. Then this is the robotic arm part of it, and then it is collecting, and then it will come back. Sorry, this part will remain on the orbit, and then the re-entry means re-entry to the Earth's atmosphere, and then there's a transfer module also, because the transfer module will transfer the collected samples to the re-entry module, as well as it will propel this one total thing to the Earth orbit. And then this is the lander module and the ascender module. These 2 will be landing on the moon, like Chandrayaan-3, the bottom one alone was there, descender module alone was there. Now this ascender module is there, and this ascender module, once this lander module collects using this robotic arm the sample. This is what the robotic arm we tried the experiment in the last PSLE mission, SpaceX mission. This was also there, and once the sample is put on the ascender module, then ascender module will lift off from the moon surface using this lander as the launch pad. Is something which is marvelous. Yeah, but you know that in the last Chandrayaan-3 mission, we tried whatever the lander we landed in Chandrayaan-3, we again ignited the engines and we lifted something around I think it is around 10 centimeter or 100 centimeter. I am not remembering the number, and we demonstrated that the capability of flying away from the, or at least lifting off from the moon surface, because we know that it is 1/6 gravity and all. These are all in papers, but reality, what is the force required to come out, lift up the mass? That is actually the experiment only will give the result. Then this is another major thing. I think I am already crossing 8:08, maybe another 5 minutes. Is it okay?
Yes, sir.
Okay. Then Bharati Antariksh Station, this is a major project, something around 2035. We are supposed to complete it. In fact, the project report says something around 2030, 32 or 33. That is there. We are supposed to complete it. It's a 5 module. Each module will be taken by our GSLV Mark III, and parallelly our NGLV, once it comes out, that also will be taking it. And this is the features of that. 3 to 4 crews, and then launch first module will be in 2028, and completion, yes, by 2035 it should be completed. And carrier is LVM3, then NGLV. This is a new vehicle we are developing, and the mass of this thing is something around 52 tons, and orbit will be around something around 400 to 450 kilometers. You know that ISS is going to be coming back. Then Chang is there, you know, the Chinese system is there and up, but then International Space Station is coming down. They are bringing back, and then once our space station is there, this also will be used by international community. So it is basically for the National Space-Based Facility to boost microgravity-based scientific research in space and related technology development. And these are all, cost is around 20 crore rupees. This is also approved program. And then comes the Shukrayaan or Venus orbit mission. This is one of the prestigious mission we have taken up. It is in 2028. Again, LVM-3 launch vehicle will be using it. And the Venus orbit injection is a very tricky thing. It will be something around 500 kilometer to 6,000 kilometer. You know that Venus will be something around, I think, 20. Average is 22, but closest is, I think, around 4 crore kilometer away, and furthest is around 44 crore. Average is around 22.5. But we will be trying with the closest part of it. Then we will be bringing back to 200 by 600 kilometer around the Venus. And Venus, you know that Venus is called as the twin sister of Earth, but we call it as evil because this is the hottest satellite. Something around 450 degrees centigrade is on the surface, and you know that once it was it believes, maybe scientifically there are certain indications are there. Venus was habitable, and somehow it lost. Either Venus was the reason or something else was the reason, we don't know. And our Venus missions will see that what has happened to the Venus, why it has lost, or why it becomes so hostile among all the planets. And salient features, these are all the things. See, this is the thing. You just see the fourth point. This is one of the very important study, the underlying causes of transformation of Venus, which is believed to be once habitable and quite similar to Earth. This is the some of the observations say that it was like that, but then maybe crores of years back, something has happened, and what it is, whether it is internal to Venus or external, that we should know. And some of our observations will be there. There are 22 payloads are there planned on that. 16 from us, 19. 22, 16 from my Indian side, 2 from Indian and international collaboration, 1 totally international. So that's what I was telling. It's a collaborative experiment, and also this will be giving as an idea of aero braking for the long space travel activities. So its a cost is something around 1,236 crores only there. These are all the list of the payloads. Anyway, I am not talking on that. Now coming to the Gaganyaan, this is always talked a lot on all the media, so I didn't make a additional slide on this. It is to put man on space, Indian on space, our brother on the space, and bring him back safely. This is the definition, very simple definition. But then to achieve that, so many hurdles we have to cross. So things are getting developed, and most probably this year itself we will be having the full-fledged Gaganyaan mission. G1 mission will be there. Rockets are ready, launch vehicles are ready, whereas the other systems are getting ready. It will be there. And then as our space minister has announced, Jitendra Prasad has announced, the Vyomitra, this is a robot. This will be there. This is also ready. This will be there in the spacecraft, and while returning, we will be recovering like this. And then subsequently there will be 2 more missions with unmanned, with space robots, and then finally we will go with our already the astronauts are selected and they are undergoing the training, and they will be taken to the outer space, and then they will be brought back safely to our country. And that will be that is the ultimate aim of Gaganyaan mission. But then it gives a lot of opportunity for further activities like man landing on moon in 2040. That is the ultimate goal we set for next 25 years. And this is the launch vehicle which takes human being from from India to moon. This is the next generation launch vehicle. This is getting developed. I was involved in the design part of it. Almost the designs are almost completed. Now this is the capability part of it is very clear, and there are so much of variations are also there. Most of the things are liquid propulsion stages. So that is why LPSC has a very lead role for developing this launch vehicle. And these are all some of the guidelines we got. It should be reusable, cost effective, commercially viable, maximally utilizing Indian industries. Now, unlike other launch vehicle development, here we are, even the design part of it, we need the cooperation from Indian industries and academies. So there are so many activities we are sharing with industries. Then reusable boosters with clustered engines, 9 engines will be there at the core of this. There will be 9 engines. So this is also first time we are aiming such type of a clustered configuration. And this hopefully another 7 years, it will be a successful realization of this launch vehicle. And then this is one slide which talks about what we are thinking by 2047, after when we celebrate the 100th anniversary of our independence, how Indian space program should look like. That's the thing. So global trends are like this, increased private participation. So we are also in that. We have already have the space reform, then 1.5 trillion economy, frequent travel to space. This also we are one of our aims. So Indian scenario is now by 2047, we should be able to get something around 0.7 trillion worth activities in the space activities, and more focus on the second order impact. That is how the societal applications of all those things has to happen. And regional alliance and leadership, of course, these are all some more political part of is also there. Space reaching to all. This is our motive. So we should get the benefits of space to all Indians. All should gain the benefit. All should get the benefit of space. So that is our motive. And the quantum communication, photonics, situation aware, all those things, these are all some of the areas in which we need to, or our academy has to come forward and give guidance to us. And ultimately, we are aiming something around 50% of the global economy for space activities. It should be 50% by us. Now it is 2%, and we are aiming another 10 years by 10%, then going slowly going back. And these are all the emerging trends in space, mining, rare materials and minerals extraction from other planets, that is from the moon. That is why we are all of a sudden, you know, that there is a big interest on the moon. After 1969, another 5 more years, there were moon missions, and then subsequently it was stopped. But then all of a sudden, there is a big interest by different nations on the moon, only because this rare metals and minerals extraction, plus of course the outer planet interplanetary missions. Moon can serve as a base. These are two things are there. Then space real estate, that is the space tourism and other things, that is the thing. Even I assume that something around 20-25 years, instead of going to some hotels in our cities, people will be going to hotels in the space. That is going to happen. That is the reality is going to happen. Farming, this is another thing. Outer space farming will be there. Then manufacturing, that is made in space products. So many of the materials we can manufacture, alloys we can manufacture under microgravity will have better properties. That's the part of it. And then this is the last slide. Always as a person, I used to get the question, how whether you will fail or how the systems are getting designed. We always design with margins, envisaging wider design space, because when we want to improve, we should have the margin with us. And then extensive testing and validating design margins and going back. This is one of the, always we are trying for that. Test as you fly and fly as you test. That is the guideline we are having. So whatever we are flying, testing in the same condition, and then that tested condition only it should fly. But of course, space is always a dangerous thing. There is no retake. We used to say that. Multi-layer robust review system. Then manufacturing with stringent quality control. This is one area. Then multi-level testing and test data review mechanism. And continuous monitoring of system parameters until liftoff. This is very, very important. Even very recent, there is one launch was there. It was called off on the last T-2 seconds. We called off that mission, and then we corrected it, and maybe after 1 hour we have. You may be remembering that. It was there in the news also, and that way it has gone. Yet, do our systems fail? Yes, they do, and we improve from our failures. That is the point I want to tell, that there is nothing in the systems which is not which is 100% failure proof. It will fail. It can fail. Anything can go wrong, especially on the space systems. That should be in our mind, back of our mind. Anything can go wrong, and we should always take care of that. And thank you all. Thank you very much for giving a patient listening. And any questions? Because I have already something around 20 minutes extra is taken. So any questions from anywhere?
Yeah. Can I ask a question?
Please go ahead.
Yeah. So I'm from like an astrophysics background.
Yes.
So I was wondering like when will be ISRO's first L2 mission and what it's going to be. My another question is like bit political. Comparing the NASA, ESA or JASA, I mean, these guys have like a very dedicated department for fundamental physics, astrophysics or cosmology. Why ISRO is not yet into like a dedicated department for that? Or why there are no dedicated fellowship for astrophysics and cosmology? Um, uh, I mean, you already talked about all the beautiful missions which is going to happen even into 2047, but nowhere there you haven't mentioned anything about fundamental physics and astrophysics and cosmology. Thank you.
Okay.
And
Anyway,
thank you very much for the beautiful talk.
Yes. Anyway, thank you for the question. Now, there are two questions, which is first one is simple to answer, because in a L2 we are not currently planning any mission. Whereas I think NASA is already or Japan, they are planning a L2 mission. L2 is far off. First thing is that, and second thing is as such we are not having a scientific. See, when we put a satellite there, there should be a clear scientific requirements for that. So if there is a scientific requirement for towards that, which can be done only in the L2, then of course we can plan of that. It's a very it's far off. First of all, its distance is more than L1. That's a fundamental thing, and going to L2 is really a tough job because it is outside Earth. It is outside. When comes to the sun on one side, L2 is outside. So going there, reaching there is really a tough job. It's a very long journey we have to take it. Such a space, but I will tell that currently our rockets are not able to take even a satellite to the L2 point. Maybe something which is worth to be having some scientific payloads. That's why. Otherwise, 5-10 kg taking there may not be a good objective for that. But if there is a real, when our NGLV comes up, definitely it can have a satellite on the L2, but then it should be backed by a proper scientific requirements. So this is what is happening in ISRO now. We need to justify the launches to the government. Each launch, who is the user, who will be, what is the takeaway for the Indian society? That is a question always we are getting from the government. So that we need to answer. And coming to the astrophysics part of it, I have not talked about anything on the academic part of it, because it is, as you told, it is a bit of politics. We are having our own Indian Institute of our ISRO IAST is there, and we are having a space physics laboratory is there, SPL is there, which is part of ISRO, which is doing some physics related maybe scientific research are there. They are giving fellowships, they are offering PhD programs, all those things are there. But astrophysics per se, I don't know whether when you are talking about NASA or ESA or JAXA is having astrophysics department, I doubt. It is all independent. These are all done by some of the universities in US. Maybe they are getting support from all these space agencies. That is what I understand. Maybe, as you told, it's a bit of political question, which involves a different direction in which this government has to take some policy for this type of things. Otherwise, because the data what we are making, it is available to all the people, and it is how the scientific community using it is up to them. It is available. We are even giving to the international community also whatever the data collected from our L1 mission, Aditya L1 mission, all are available on the portal, and one can collect and study on that.
Thank you very much. Yeah, I'm really really looking forward to a time where ISRO can do L2 mission.
Yes,
Yeah.
definitely. In fact, I myself asked this question to some of our higher-ups, but then there was no. They were telling that we are not able to justify the launch with a proper scientific explanation or requirement. But L1, we could manage. Now, once L1 is achieved, definitely L2, but it's a tough job to go to L2. Is a really tough job. There is already one satellite is there in L2.
Yeah, there was a proposal from the Indian cosmology community, astrophysics community for like a satellite called CMB Bharat. Maybe you might have heard about it, which was supposed to take the signals from the Big Bang or the near Big Bang. Unfortunately, it didn't went through some stages of ISRO, I guess. But yeah, I mean, JASA is doing the same thing, which is going to be like launch in 2032.
Correct.
Yeah.
Okay, these are all because it involves one, but they as a total proposal when we are discussing, it should be in totality. We have to discuss that and how we can make the satellite for that. The science payload is one part of it, but then making it into a reality. Because first of all, what type of propulsion system we need to have for something on the L2? We should go for something around nuclear propulsion or something like that. So these are all things to be developed. That is why. But I am not I am not having any idea about the CMB satellite proposal, because basically I was working in the launch vehicle area.
Thank you, sir.
There was one question was appearing, but it got disappeared in it. There is Raj Kiran, I think. Can you please explain about the future of liquid propulsion systems, and does it face any current challenges? Future is always there without liquid propulsion. This is one book is written in 1948. I forgot that is Ignition. The book name is Ignition. It is written in 1940. It's a very old book. It's available in the internet. You can download. If you see that there, the last sentence on almost end of that, liquid propulsion will always be there for the space application. Without that, there is no space activities. That is a statement made in that book. Basically, there are other propulsion systems having its own complications. If you say solid, of course, it is having very less performance. Cryo, very high performance, but the problem is it is very difficult to handle. Liquid propulsion is very easy. No new things are coming. Semi-cryo propulsions are there. Whereas nuclear propulsion and all is very complex. It's very complex. It is having very high performance measures, but it's a highly complex, and there is no. I think there is only one satellite that has gone with that. And deep space applications, definitely we should have such type of things. But then rocket propulsion and the near Earth orbital propulsion, definitely the liquid propulsion is always should be there. Maybe electric propulsion can replace some of the satellite propulsion systems, but otherwise it's a requirement. It is always having the future. But the challenges are many, because the normal air storable systems are highly poisonous. It's carcinogenic. We should have a green propulsion system. Of course, LOX methane and LOX, it has come as a promising candidate. So that is the advantage of that.
Yet another question is asked in the chat box regarding Kessler syndrome.
Yeah, I am not able to comment on that. Yes, can you please explain about Kessler syndrome? Is there anything to worry about as the media says? I am not clear on that. I am not able to answer that question.
I had a question to ask.
Please.
In these days, in everything, we are using AI and machine learning. So how does this research is going on in ISRO?
AI we are trying to use in our quality control, manufacturing, and in many areas we are trying to use. But then application of AI in other areas like electronics, part of it, there is no much research is happening there. But the application of AI we are trying to use in our quality control systems and other areas. Machine learning, of course, once we are going with our robotic systems and other things, definitely we should have it. But there is no major activities are happening as such in ISRO currently in this area.
Okay, thank you, sir. Are there any other questions? Okay. There are no questions, I think. So please fill out the feedback form. I think it is time to conclude. So thank you, sir, once more.
Thank you. Thank you very much for giving me this opportunity. And I took, I think, double the time allotted to me because I am not clear about the audience to whom I was talking, and I was told that it ranges from our +2 students up to the professors. So I thought I will touch up almost all areas where I have worked. That is why it becomes a lengthy presentation. Thank you very much. Thank you.
It was a very informative talk. Thank you.
Thank you. Thank you very much.
Thank you so much, sir. Thank you.
Thank you, Karthik. Thank you.
Thank you, sir.
Thank you. Thank you.
Yes, sir.
Thank you all once again. Good night.